Now coming to the types of the semiconductor. Based on its structure, semiconductor is divided into two types: a simple or single crystal semiconductor, a compound semiconductor. Single crystal semiconductor name itself defines that it is a single element. So, each and every fourth group element can be considered as a semiconductor except carbon. Carbon is not a semiconductor. As we know the organic properties of carbon, carbon is an organic element. Coming to the compound semiconductor, the name itself indicates that it is constructed by two or more semiconductors materials with different atomic structures. It may be a third A group element and a fifth A group element, second A group element and sixth A group element. The fourth A and fourth A to be neglected. The main preference is given to the third A and fifth A, as the third A is deficient of one electron and the fifth A is ahead of one electron. So the fifth A act as the fifth A act as the donors and the third A act as acceptors. So the combination of this third A and this fifth A gives a semiconductor. Now talking about the properties of semiconductors. So here there is a list of 11 properties of semiconductors, silicon and germanium. So firstly, atomic number. Atomic number of silicon is 14 and germanium is 32. Number of atoms per centimeter cube. It means the density is 5 into 10 power 22 and 4.4 to 1 into 10 power 22. What is intrinsic concentration? Intrinsic concentration of a silicon semiconductor is 1.5 into 10 power 10, whereas germanium is 2.5 into 10 power 13. Intrinsic is nothing but the pure form of a semiconductor. Now coming to intrinsic resistivity. Resistivity is nothing but which stops the flow of electrons, right? So the intrinsic resistivity of silicon is very high, that is 22,30,000, whereas for germanium it is 45 ohms, 45 ohms, and this is 230K, and this is 45 ohms. Now coming to electron mobility. Mobility is nothing but the movement of electrons. Electron mobilities of silicon is 1300, whereas whole mobility of silicon is 500. Now the electron mobility of germanium is 3800 and the whole mobility is 1800. So when we compare the entire mobility of silicon with the germanium's mobility, mobility of germanium is very much greater than mobility of silicon. Now coming to the energy gap. Energy gap at 0 Kelvin is 1.21 electron volts. For germanium it is 0.175. Similarly, the electron gap, energy gap at 300 Kelvin of silicon is 1.1 and germanium is 0.72. And these values, energy gap values, are very important. Leakage current. Leakage current is nothing but the minority carrier current. At 300 Kelvin, silicon minority leakage current is expressed in terms of nanoamperes, whereas in germanium it is expressed in terms of microamperes. Maximum operating temperature. So it is known as the temperature, the highest temperature at which the silicon or at which the semiconductor operates. It is 175 degrees for silicon and 75 degrees for germanium. And the power handling capacity of silicon is high power and germanium is low power.